Law of conservation of momentum. In any collision or explosion, the total momentum remains constant. In other words, momentum can't be created or destroyed. But momentum can be transferred between objects. When we talk about law of conservation of momentum, we're going to deal with collisions and explosions. Collisions are when two or more objects come together. And at least one of those objects has to be moving in a collision. An explosion is when one object becomes many moving objects. And that one object is not necessarily at rest to begin with. Now, when we talk about motion, we need to have direction to go along with it. So negative numbers tell direction of the motion. So let's look at an example. Let's look at an example of guns and bullets. So let's write some data down first. Let's say that the mass of our gun is 2.5 kilograms. And the mass of our bullet is 0.05 kilograms. And the bullet, when it's shot out of the gun, has a velocity of 400 meters per second. Now, some information that we know. Because of the law of conservation of mass, we know that the total momentum before the shot must be equal to the total momentum after the shot. So let's talk about before the bullet is shot from the gun. Well, the total momentum would be 0 because we have no motion. So now let's talk about after the bullet is shot from the gun. Again, the total momentum has to equal 0 because of the law of conservation of momentum. But this time, the gun has fired the bullet, so we've got momentum going towards the left for our bullet. That must mean we've got momentum going towards the right for our gun. And let's say that our bullet is going at 400 meters per second. We want to calculate the recoil velocity of the gun. Well, we can calculate the bullet's momentum. Remember that momentum equals mass times velocity. So the mass of our bullet is 0.05 kilograms, and the velocity of the bullet when it leaves the gun is 400 meters per second. So that's going to give us a momentum for the bullet of 20 kilogram meter per second. What do we know? After the bullet is shot from the gun, we know that the momentum of the gun and the bullet together must equal 0. Well, we calculated the momentum of the bullet. We said the momentum of the bullet is 20 kilogram meter per second. In order for the total momentum of the gun and the bullet to equal 0, that must mean that the gun's momentum must be the same, but in the opposite direction. So velocity will equal the momentum divided by the mass. We know that the momentum is going to be negative 20 kilogram meter per second, opposite and equal to the momentum of the bullet. We'll divide that by the mass of the gun, which is 2.5 kilograms, and that's going to give us the velocity of the gun, or the recoil velocity of the gun, as negative 8 meters per second. And that negative sign tells us that it's going to be traveling in the opposite direction of the bullet. Now let's talk about collisions. A collision is when two or more objects come together. And there are two types of collisions. We've got elastic collisions and we've got inelastic collisions. Elastic collisions are when one object bounces off of another object. There's no lasting deformation, sound, or heat that's generated in an elastic collision. We're just looking at the transfer of momentum from one object to another. And these are typically not common types of collisions. Next, we have inelastic collisions. And inelastic collisions occur when objects stick together after the collision. The masses are combined so the objects move slower after the collision. So let's look at an example. Let's say we've got Buzzy the bug and a bus. And let's talk about some data. Let's say that the mass of Buzzy the bug is 1.0 times 10 to the minus 5 kilograms. Remember, that actually means 0.00001 kilograms, a very small mass. And let's say that Buzzy's speed is 3.0 meters per second eastbound. Now let's look at the bus. Let's say the mass of the bus is 3,500 kilograms, and the speed of the bus is 28 meters per second westbound. So we have some questions to answer. Our first question is, who has more momentum? And remember that we calculate momentum by taking the mass times the velocity of an object. So the answer to who has more momentum would be the bus. And the reason for that is the bus has both more mass and more velocity. So our next question says, in what direction is the total momentum before the collision? And that total momentum will be in the direction of the bus, which is westbound. Does Buzzy add to the bus's momentum or subtract from it? Now, if we think about the movement of Buzzy the bug and the bus, they're in opposite directions, so we're going to be subtracting the momentum. Why? Because they're moving in opposite directions. In what direction is the total momentum after the collision? And again, that's going to still be westbound, or in the direction of the bus. So now let's look at a couple more questions. Is momentum conserved when the bus and the bug collide? Yes, momentum is conserved. Who hits harder? And that would be equal. Now think about that for a second. Who says that? Well, Newton's third law. We know that for every action, there's an equal and opposite reaction, or for every force, there's an equal and opposite force. So the force Buzzy applies to the bus is equal to the force the bus applies to Buzzy. Who has the greater change in velocity? And that would be Buzzy. And again, we want to know why. And that's because he's going eastbound and now he's going westbound. Does the bus slow down? Actually, the bus does slow down. It's a real small amount, but it will lose velocity. Why? Because we increase the mass when Buzzy sticks to the windshield of the bus. Since the mass goes up, the velocity must be going down since the momentum stays the same. So our last question is, what if Buzzy were an elephant? Now the bus would have a greater change in its velocity because we'd be adding more mass to the bus, which would make the velocity go down even greater.